Here we are again with the newly acquired Schneider EuroPC II. I have connected it to power. I have connected it to my TV with a SCART and a CGA to SCART adapter. You should check out my video on that. And we can turn on the machine, but we can't use the keyboard. So you are hereby invited to join me in figuring out this machine and make it run. Let's have a look inside. Okay. It was not connected. First we'll take a look and check for battery leakage. Well, there is no battery here. Compared to my EuroPC I, I see some differences. We don't have this unit. I guess this is some sort of a power supply. I also see that the new power supply on the EuroPC II is a lot smaller than the one on the EuroPC I. So I guess that some of the electronics are moved from this power supply to the motherboard. So as we can see, it has been a battery here. We can see the square that is marked with the BAT1, and we can also see some sign of battery leakage. So it definitely had a battery, but it is removed now. And if we are lucky, the damages are not too great. I'm using Absolute alcohol, Prima, with only 2% something. I prefer this because it's a strong solvent, but it also vaporizes very quickly. Some compressed gas. Okay, I think I'll clean most of it, but I just want to turn it around just to be sure that there is no leakage or any damage on the back side of the PCB. It was only connected with the three clips here in the front, and in the back the mouse port was connected with these ordinary screws. I have not seen that method before, but it was a clever way of connecting it. So let us just turn it around and have a look at the back side. This is the back side of where the battery is. You can see these are the connectors for the battery, these 3 pins here. The battery is not soldered out, it's just cut out. That's okay. At least for now, since we're not replacing it with anything at this moment. I used a multimeter to measure some of the damage traces, and as far as I can tell, they all conduct electricity. So I think we are ready to give it a try. I have connected the power supply, the CGA to SCART, I've connected the keyboard, I found a floppy disk we can boot from if it works. So let us test it. Okay, that was not the sound of success. It's a lot of error messages on the screen, but maybe it's just the CMOS setup that is not configured. Let us try Control Alt Escape. Oh yeah, good. Oh, Norway. Well, since I'm Norwegian, I'll use that. I'll set the correct, no, I won't, I don't have a watch. $720, okay, so the internal drive was not connected. It says external drive 360 will not install on that. Boot drive internally, we'll choose color on the internal video, startup video, color graphics. Yeah, let's choose color graphics. Monitor detection enabled. Okay, I don't know if that will work with a CGA to SCART, but we'll see. Illegal memory config. Ah, okay, so we can choose 640 or 512 plus 256 or 640 plus 128. Let's do that. 640 plus 128. Hard drive not installed. Joystick port disabled. And speed, let's increase it. Yeah, we can choose between 4.77, 7.15 and 9.55. Let's do that. Enter to store information. Ooh, it's promising. Ooh. Okay. Real-time clock error, speed setup error. Okay, so it defaulted back to 4.77 megahertz. Hard disk setup error. Okay, basically we're all back to all the errors we had. So it doesn't. No, it didn't store any of my settings. I have decided that I will try connecting a coin battery, 3.2 volts, 3220. 32 is for 3.2 volt and 20 is for 2 millimeters high. First I need to take off the old soldering, and then I need to solder this battery holder with just 2 wires, just preliminary, so we can test if it will work with the battery connected. So it says here on the bottom that it's plus, so, and also that is correct according to at least the Varta batteries I've seen. They have 2 connectors on the plus side. I have soldered on a battery holder. I said 3220 I think, but it's the battery says 2032, so I remembered wrong. But still, 20 means the thickness and 32 is 3.2 volt. Let's give it another try. Okay, the power on light is lit and the floppy disk light. Let's cross the fingers. Oh, CPU speed, it's now 9.54. It says internal floppy drive enabled disk error. Okay, we are a long way closer to fixing this. Now it only says floppy drive error. So now we have to figure out why. Lucky once again. This this was the floppy drive that was in the machine. I took the floppy drive from my first EuroPC, and I know that floppy drive works. So I just used that instead, and the floppy drive booted instantly. Nice. So now we have two things we can try. We can dig a little deeper on that floppy drive that don't work and see if we can figure out what is wrong. Or we can just put a GoTech in this one. I think I'm going to try to have a second look at the floppy drive before I make up my mind. But I'm very happy so far because we know that the motherboard is working. It saves the CMOS setup. We don't know if the clock is working. So let's enter a time here. Let's give it a restart and see. No, it's something wrong with the clock or the CMOS or something, because the time is now reset back to 0. So the only thing we know that is faulty now is the clock and the floppy drive. So let's continue digging. I have not been successful finding any fault on this floppy drive. I've taken it apart. The first thing I did was examining all the electronic components that are visible on this side. Basically, I just studied them through the magnification glass. As we can see, there's a lot of SMDs here. Not easy to spot anything wrong on this kind of electronics. I also removed this plate and these screws we see here, and took this off and turned it on the other side to look for any faults there. I could not see anything. In case it was the motor that had a fault that maybe created a short circuit, I removed the wires going to the motor. That did not help. I also removed these wires going to the head or the reader. Nothing helped. What we know is that when the drive is connected, the drive light is on all the time, and we also know that the machine beeps and says it has a disk error long before it even tries to boot from it. So there must be something seriously wrong with the electronics. So at least for now, I'm gonna stop working on the floppy drive and just put everything back together, because I have one more EuroPC that I will try to repair. Well, if it needs to be repaired, I haven't tried it yet. But anyway, I'll just leave this for now. I know that it will work with a GoTech because I've made a video about that earlier on how to connect a GoTech to the EuroPC. So here we are. The floppy drive is still not working, and the clock is not correct. Let's try that. No. So I've connected it all back again, except for the floppy drive. It's not connected. I've also disabled it in BIOS. But I have added a ESA XT IDE card with a CompactFlash. And as we can see here, we have successfully booted. So as we can see, it is working. We are running Planet X3. Very satisfied so far. Let us run Norton Sysinfo and just see what it says about this machine. It says it's an 8088 at 10 MHz. Let's go straight to the benchmark. And this computer is 2 times faster than an IBM PC or XT. Here is a box of NEC V20s and NEC V30s. I'll think our next project here now is to install a NEC V20 in this 8088 machine. This is what the CheckIt 3 says about the machine. 8088 XT, 640K of memory, the main system. And check the CPU speed. It says 8088 9.54 MHz. And there we have it, about twice as fast as IBM PC. So let's save that. And let's do a hard disk test. Yeah, it's 2.6 times faster than a PC. And on average seek and track seek, it's way faster. So let's save this too. So now we have done 3 speed tests. Now I want to insert this NEC V20 and run the same tests again and see what results we get. Here is the old 8088 from Siemens. And here is the new NEC V20. Now CheckIt says that the CPU is a V20 running at 9.55 MHz. And the speed is rated as 2.26 times IBM PC. And compare with the result we just ran with the old CPU, it's 1.13 times faster. The transfer speed on the CompactFlash disk is 1.09 times faster, so about 10% faster. Norton Sysinfo agrees. It now says that it's 2.1 times faster than original IBM XT. Previously it said the speed was 2.0. Now that we have upgraded the CPU to a NEC V20, we can also upgrade the XT IDE BIOS to a version that is compiled to utilize the 80-186 instruction set. And that should also increase the speed of the CompactFlash hard drive. Before flashing the EEPROM, make sure that you choose the correct EEPROM and the correct address for the EEPROM. You can see the address on the dip switches or when booting the computer. Running CheckIt again, we see that CompactFlash is now 2.13 times faster than it was before the upgrade. So while cleaning the keyboard, I was thinking on what to do with my 2 problems, the floppy drive and the real-time clock. I then decided to steal the floppy drive for my 3rd EuroPC, which motherboard I have been unable to repair, at least at this time. So then I only had the real-time clock left to fix. With some help of my friends on a Facebook group, I was pointed in the direction to a couple of videos that talked about real-time clock and how to repair that. And there I learned that the most probable cause was the crystal that supplies the clock signal. One easy way to check if the real-time clock is working is to enter the BIOS, and if the seconds are not counting, well, something is wrong with the real-time clock. When taking a second look at the PCB, we clearly see that the crystal, that blank metal thing in the middle, shows a sign of damage. So let's start by replacing it. I have now removed the crystal and replaced it with a brand new one, and as you can see, it's shiny and nice. And now the seconds are counting. So that fixed it. There is one more thing that I feel I need to do before I can close this case, literally. And that is to make a better battery replacement than the one I made. So I decided to make a battery holder by just cutting off a piece of some PCB I had, and by cutting off 3 pieces of these feet, whatever you call them, and soldering them to the PCB, they actually fitted perfectly in the 3 holes where the Varta battery used to be. So to make sure that the computer does not try to recharge the coin battery, I am installing a diode between the battery and the plus side pins going to the motherboard. Here we can see the device I made installed. It fit perfectly on the motherboard. After soldering the 3 pins on the back side, it felt good knowing that I had repaired this real-time clock as good as I could. Yeah, that was a job that felt good. I completed my Schneider. We have fixed the battery leakage. We have fixed the real-time clock. We have added a new NEC V20. So it's now about 10 to 13% faster, at least according to CheckIt. And because we have a NEC V20, we now can also use the 186 instruction set on our XT IDE BIOS. And that gave us twice as fast hard drive, or CompactFlash in this case. Well, only one thing left now, and that is to enjoy a game on my favorite computer of all times. And I hope you liked this video. If you did, I would be very happy if you press like.